Okay, friends, so here we have another simulator I built for us that keeps track of how many coins it takes until we get both sides. I bet you've already figured out the minimum number it takes is 2. You could go heads, tails, or tails, heads. Here's where it gets interesting, though. Technically speaking, there is no maximum number. It is possible, although highly improbable, that you could keep flipping a coin over and over and over and never get the other side. You could just get heads, 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 heads infinitely. I don't know why, but The Simpsons just popped into my mind with the guy that had hiccups for like 17 years. Anyway, it's possible, but not probable. And we'll talk more about that in the next couple weeks. So what I'm going to do now is I am going to simulate a lot of these experiments. It's the same exact idea I kept track of up here, except what you're going to see is you're going to see a lot more situations where you end up with a like for example right there. I just wanted to stop at one. That flipped 8 heads in a row followed by tails. Okay? That would not have existed in our last experiment. We would have been done after 2. It would have gone heads, heads. Now, what you're also noticing, I hope, is not just, it's easy for humans to stop this simulator when you get to something quote unquote interesting like this, or something, I just missed one, something interesting like this, or something interesting like that. But what you really should be focusing on, not the human side, the analytical side, look how many end at 2. There's a lot. And I'm going to hold down this F9 button. I'm actually going to put a stapler on it to hold it down for us so we can chat to each other. I'm going to create a whole bunch of data. Hopefully you're noticing what's going on here. Down here at the bottom, I'm keeping track of total trials. So far we're creeping up on 500, and we'll get a few hundred here as we chat. Assuming this is good, random, unbiased data, the more the better. Something interesting happened as we weren't paying attention. We got a run of 13. Did you see that? That little 1 right there? That's kind of fun. I'm going to let it run a little bit longer. I'm going to speed it up here, actually, and then we'll regroup. Okay, so we have 5,000 trials. I was enjoying watching the patterns. It was fun kind of watching in the middle here, these numbers kind of eventually fill out, and then kind of a little fun surprise. There was an 18 there towards the bottom. And if I let this run hundreds of thousands of times, I would probably have to make this table go even further. Because eventually, as you saw, over time, these numbers begin to fill out. It's just that you require many, many, many trials for those very rare occurrences to show up. I actually let my computer run overnight last night, and when I came back in this morning, it had turned itself off. So I think I need a better machine before I pull that kind of stuff off. Okay, we now have 5,000 trials. What I'm going to do is I'm going to make this spreadsheet right here available to you. We're actually going to calculate the average number of flips it took based on this data. So take a look at this right now. You have any idea what the average number of flips is yet? Could you tell by looking at this? It's okay if you can't. Let's take a quick pause. I'm going to clean this spreadsheet up, and you'll have it available to you, downloadable next to these videos. Okay, friends, I've cleaned up the spreadsheet for us a little bit. We now have all the pertinent data to calculate the averages. And there was a lot of stuff in the spreadsheet that we don't need to do the average, but it was all necessary for doing the counting. Now we have the data, which is the number of flips to get both sides. And then we've got the frequencies of those things that occurred. A lot of these ended up with 0 frequencies. I left them in. It doesn't hurt to have them in. It doesn't hurt to take them out. Okay, now if we were to do this average manually, it would look something like this. And we'd have to work through 2,534 times 2. And then we'd have to add to it 1,238 times 3. And then we'd have to add to it 574 times 4. And we'd have to do that all the way down until we got to 1 times 18. And we'd have to add all that up, and then we'd have to divide by 5,000. And we'd get the answer. I mean, we totally would get it. It would take a long time, but we could get it. I think what we should do is we should learn how to do it in Excel. I think we should. So let's get ready to do some coding. What I'm going to do is I'm going to create a column right here in column E. Okay, column E. I'm going to call this flips times frequency. Okay, and if you want, you can change the background to match it. It's bugging me a little bit that it's different, so I'm going to change it. I'm going to bold it. I'm going to underline it. What this is going to do is it's going to take each number of flips and multiply it by its frequency of that number of flips. So for example, we saw 2 flips 2,534 times. So in this column right here, I'm going to type the formula equals that times that. So look at that formula. It's just C3 times D3. When I press enter, it tells me 5,068. And the reason it tells me 5,068 is if I had 2 flips 2,534 times, that means I got 5,068 total flips. And once I have that formula in cell E3, I can drag that formula all the way down, and it's going to repeat the same calculation for each line. There must be 3,714 flips as a result of doing 3 times 1, 2, 3, 8. There must be 2,296 flips as a result of this, 1,600 flips as a result of this, and so forth all the way down to this little 18 that's down here. Okay, I'm going to lightly shade the background of this because I'm feeling it. Okay. Now, we know how many trials we ran, 5,000. So we know we're going to be dividing by that total number of trials. We now have to add up all of these results here. So in this cell right under that list, I'm going to type equals, and here's a fun command, sum, S-U-M, left parentheses, and then I'm going to select all the data above it. I'm going to close the right parentheses up, and when I press enter, Excel is going to add up all those numbers. Let's do it. 14,999 flips happened as Excel was, quote unquote, flipping its coins. 14,999. That's totally awesome. We'll come back to why in a second. Okay, so we flipped 14,999 coins over a total of 5,000 trials. So over here, what I'm going to do over here is we're almost done. It's one quick calculation and we're finished. We have to divide that number by that number. Now, some of you might grab your phone and do that divided by that, but you can also do it in Excel. So I'm going to type not equals, but just the word average, because that's what we're going to be calculating. And then next to that cell, I'm going to type equals, and I'm going to click the 14,999, and I'm going to press divide, and I'm going to click the 5,000 and press enter, and you're going to see that it says 3. Now, it's not actually 3. It's 2.9998. You're able to take a large data set and calculate its average in 2 ways. 1, manually, and 2, using Excel, and that's pretty rad. Let's stop flipping coins. Let's move to dealing cards.